Good evening, good afternoon, or good morning from wherever you're joining us from today. My name is Sarah and I'm the Program and Event Manager at the Reactor in Sydney, Australia. Welcome to a Microsoft Reactor Sydney livestream event. Today I would like to welcome back David Glover. David is a passionate software developer working for Microsoft in the UK and Australia across customers, partners, and the developer community. Over the years, he's covered a broad range of technologies from Windows and mobile, web dev, IoT, communications, and cloud-centric computing. So this evening, we will be discussing building the healthy, safe spaces, edge-to-cloud solutions with Azure Sphere as part of our IoT series that we're doing this month in November. So you'll see in the the comment section there, we've got the check-in link with the event code 14872. So all the links that you've seen tonight in Dave's presentation are all in that check-in link. We'll be talking for about an hour, and please do send us your questions throughout, and between Dave and myself, we'll try and answer as many as possible throughout and towards the end. You'll also see I'm going to share with you a link to the feedback survey with the same event code 14872. If you could fill that out at the end, that would be awesome. And this will be available on YouTube as well. So the on-demand version will be up on our YouTube channel straight after today. So if there's anything that you missed, you can go back to the session and reference it later on. I'll provide that link also towards the end. But for now, I'd like to hand the floor over to Dave to begin. So thank you so much, Dave, and over to you.
Absolute pleasure. Thanks, Sarah, for the introduction, and welcome, everybody. As Sarah said, my name's Dave Glover, and I'm an IoT developer advocate. I'm actually based in Sydney, Australia, and kind of have a pretty global role. I can be followed, or please feel free to connect with me on Twitter, and my tag there is @dglover. Now, as Sarah said, this session here is about what I did to create this healthy spaces with Iit Central and Azure Sphere. Now, this project, unfortunately, the inception behind this project was the pandemic and this kind of working from home or moving to work from home. And of course, what's happened is that we've moved from offices which are really fairly well ventilated, often into quite snug spare rooms we might have in our homes and things like that. And what I found here, because I actually set up this CO2 monitor in my own home, is I found some of the rooms that were being used as offices, the CO2 levels really skyrocketed. In fact, in the room that I'm going to show you the chart for mine, and I'd find that I'd often be spending a lot of time talking, like I am now, and kind of getting halfway through it and thinking, I don't feel kind of that great. I've got a bit of a headache and slightly fuzzy. And I figured out, actually, I put a CO2 monitor in here and I actually found out it was actually just me talking away and the CO2 levels building up. And as I did more and more talking, the less capable I kind of got. So that's kind of the reason for this application. Now, down in the second part of the slide here, we've got a link off to the solution. And I'm just going to bring up the solution here. And so fear not, as I go through this talk, you might think, oh man, what did he talk about? He went through that a bit quickly, and I lost track of where he was at. So the full solution is documented up on that link. So if you want to pop a screenshot of that, I think the link's in the chat as well. And but the full solution is documented on this web page, on this GitHub repo for Azure Sphere Gallery. And it kind of goes through what Azure Sphere is, uses a library called DevX, supported hardware configurations, using CO2 sensors, various devices, and things like that. So I'm scrolling through this quickly, deliberately, because just fear not, if you lose track of where I'm at, then you know that you can head off to the location down here for this to get more understanding about the project. Okay, so the next thing is feel free to ask any questions in the chat window. And actually, it was kind of interesting. I was talking to Sarah before. Did we know where you were coming from or where you were? So feel free to put in the chat window just kind of what country you're based in. And I'll keep a bit of an eye on that. And also feel free to ask any questions. And I will try and do my best to keep an eye on the chat window. And if I can answer then and there in the context as the conversation, and it makes sense to stop there and I'll talk about it. So feel free to ask ask questions. If it makes sense, I'll answer them then and there. Failing that, I'm going to answer them at the end of the session. So as I said, chuck in a comment in the, just say, hey, look, where are you from? Alrighty, so we're going to get started. So the agenda for this session is we're going to talk about CO2 and healthy spaces. We're going to look at the overall solution architecture, and then we're going to look at the developer experience. So that's kind of roughly what we're going to talk about. Actually, what's not on this agenda is I'm also going to talk a bit about some best practices. So we'll get to that towards the end of the session. Okay, so be aware of CO2 levels and their impact on health. And you can look around the internet, and this is based on various bits of data that I've gleaned from the internet. And it kind of gives you a bit of a sense of what a healthy CO2 levels are and what not so healthy CO2 levels are. So if we look at the kind of the great outdoors, then generally the CO2 levels are around about 350 parts per million. So that's kind of roughly what they are. If you're indoors and it's acceptable levels, then it's roughly around 400 parts per million. If you start getting closer to 800 or between 800 and 1,000, that's when you start to feel like, I feel a bit achy, or I'm just not feeling great, or there's something just not quite right. And if you start getting closer to 1,000, then that's when you start to feel a bit drowsy. And then that's when you can be in a meeting, and maybe the meeting's boring, but maybe the meeting is just because you're in a confined space and you don't have enough ventilation and the CO2 levels are building up, and you're actually putting yourself to sleep. And then when you kind of get to what we call adverse levels, that's kind of when it's getting to 3,000 parts per million. And that's when you start to get a problem in the solution, in kind of the CO2 levels. And this is actually, this was actually real data in the room that I was working in. And this is kind of what inspired this overall solution. So you can see I had the door closed, and I had the room closed, and I was making a recording or doing a presentation or something along those lines. I was doing a lot of talking. And you can see in here that the CO2 levels in my room actually got to 1,600 parts per million. Now that's actually quite high, as I said before, and that's when you start to get drowsy. And I must admit, I think I remember at the time I was doing some recordings and I was just losing my concentration. And I think I actually figured out this is what part of the problem was. So I've been much better at kind of opening the window. And I also use noise cancellation software on my microphone, so that hopefully cancels out stuff, so I can have the best of both worlds. My window open and noise not going through onto a call that I'm on. So this is kind of what inspired it, and it's super easy, particularly if you're working from home. Often we've got kids at home, we want to close the door because we've got meetings, and it's these types of scenarios that this project was kind of geared towards. Now, you may or may not be familiar with what the term Internet of Things is. And actually, it's being more often referred to as edge to cloud solutions. It's kind of broadly what it's been called nowadays. So we've kind of got things, and things are microcontrollers, and attached to those microcontrollers typically are sensors. And on this solution, I've got a CO2 sensor, I've got a humidity sensor, I've got an air pressure sensor, and I've got a light sensor on it too, actually. So that's the thing that's sensing the data, and what it's going to do, it's going to send this data to the cloud, or to IoT Hub in this case, or Iit Central. And then the next part of the kind of an IoT solution, what we call a reference architecture actually, is we kind of got insights. And we want to go and build insights and understand what it is about that data. So we kind of build insights so we can go and do reporting or understand and things like that. But often what we want to be able to do is we want to do kind of meaningful actions based on those insights. So we can look at maybe the CO2 level has gone above a certain level. Maybe an action is to, if it's in a building, to notify the building manager to say, hey, look, on this particular floor, the CO2 levels are actually getting unacceptably high. Can you check on the HVAC system, the heating, ventilation, and air conditioning system? Maybe it's broken. So those are the types of things. That's the kind of idea behind Internet of Things application. You've got things that generate data, you've got insights based on that data, and you've got actions based on the insights. So I want to talk a bit about what component pieces were made, what components I used for the solution. So on the things end of the scale, so the devices end of the scale, I used something called Azure Sphere. Now, Azure Sphere is a secure IoT or edge platform. And the whole kind of reason for it, or the design point about it, it's designed to be secure system, and it's designed to be secure by default. And I'm going to talk a bit about what that means when we get further into the talk, particularly around what it means to be secure by default, which basically means everything's locked down. That's kind of fundamentally what it means. Okay, and the second part of this talk, the second part of the solution is called Azure Iit Central, which is a web portal that you use to go and build IoT solutions. And in this case, Iit Central is acting as both the insights as well as the actions. So remember that we've got things, insights, and actions. So we've got the things coming from Azure Sphere, which is a secure IoT platform or edge platform, and we've got Azure Iit Central, which is a web portal, which the easiest way to think about it, it's very low code, no code web portal where you can kind of describe and almost declare what the portal will look like. And you'd create these things called views. And obviously we're connecting these things with the internet and using secure protocols to do that over the internet for transferring data backwards and forwards. Okay, so the first thing I'm going to talk about in a bit more detail is Iit Central. So Iit Central, it's a fully hosted managed service by Microsoft. And the idea behind it is it's a low code, no code, so you don't have to be a developer to go and use it. You kind of describe it and you create forms and things like that. And we deal with device connectivity management. You can go and create rules and triggers extensible. You can push data out of Iit Central into Azure Storage, for example. You might want to keep an audit of data in the Azure Storage, and maybe go and use it to train a machine learning model, or those types of things. It's also free for 2 devices, so you can get it up and running with it really easy, and it's a really nice solution for really kind of proving out the value of an IoT solution. And that's what I love about it, because you can spend quite a lot of time developing an IoT solution on a device, and then you can often be struck with, okay, now I've got to build out a cloud solution. And you need all the developer skills, and it's kind of a different skill set to go and do that. With Iit Central, it's really a no developer, low code, no code experience, developer experience. And in fact, what I'm going to do is kind of give you a bit of a demo of how it works. So I'm going to bring up Iit Central, and actually just make, okay, so what I'm in here, so I said it was a web portal, and we'll just close it up. And so this is the web portal, and I'm just going to talk around, kind of go around this pretty quickly. So we've got this kind of concept of dashboards, and you can create multiple dashboards. So you can see in this one here, I've got 2 devices. I've got one which I've called Seed Studio, and one which I've called Micro eClick. They're not particularly descriptive names. They're descriptive for me because that's a technology that I'm using for the particular scenario. And you can see the one in the kind of pinkish purplish line. I've only just started this device up, but this other device I've been running for long term. Actually just sits in my bedroom and just kind of monitors CO2 levels. And you can see these are the 2 devices I've got on down here. If I go and click on the Seed Studio device, I can come and look at overview, and there I get a nice fancy chart. I can turn bits and pieces off, so I can drill into data. You can go and change the format of the charts. You can expand it. You can export the data out of it and things like that. So you can go and do what are called markers and kind of do some interesting things. So it provides a really nice way in which you can navigate around the data that you're receiving from an IoT device. And you can see, so this big chart over here is what it's called telemetry. This is telemetry. This is basically streaming over a period of time. I have a 24-hour window actually on this one here. So what's happened in the last 24 hours? You'll see over here on the right-hand side, these are what are called properties, and these are kind of points in time. And you can see the point in time for this particular CO2 sensor for the parts per million is 476 parts per million, which is probably not too bad. The air pressure at the moment in Sydney is 1,016, and the temperature, it's probably slightly overstated. You could probably do with a bit of calibration. It's probably, it's actually about that temperature in the room. And the humidity is about 43. For kind of more diagnostics purposes, I also stream up memory usage. I just kind of like to watch what's going on and just make sure the platform's behaving properly. So that's the kind of the first thing around these views. And you've got different views. So you've got this about view down here, and these are actually what we will call properties. So you can see I've got an alert level here, which sets at 1,000 parts per million. Interesting enough, the altitude that the device is sitting at has actually quite a significant impact on the accuracy of CO2 sensors. And I'm sure you appreciate the higher you go, the less dense the air goes. So if you say what height you're at, the CO2 sensor automatically kind of calibrates based on the height and will give you a truer view of the CO2 levels. This is the current CO2 level, so it's 481. Current temperature is 27, humidity is 43. You can see the rest of those properties in here. I've also got the ability to go and set settings. So I could go and set an alert level. So for example, I could go and change it to 400. And then I've got a little beeper on there, which would be a little bit annoying. And will start beeping to say, hey, look, the CO2 levels are above the level that I've set. And you've got commands, and you can go and look at the raw data as well. So you can kind of dig into the data of what's coming through. Why isn't that not showing me? Oh yeah, there we are. So there goes the raw data. So that's the kind of the idea behind you have these views. Within this main devices view, I can go and manage the template. And remember how I said this is really no code and low code. So this is the model. So what we have is a model which describes the telemetry. This is normally done by the developer. And in this case, we're using something called plug and play. So the device, when it connects up to Iit Central, will say, this is my plug and play schema. And in this case, what I'm going to do is I'm going to grab a schema from a public repository of schemas for Iit Central, which describes the capabilities of this CO2 sensor device. And so what happens is that gets done by the developer, and then you connect that to Iit Central. And the first thing in the application will do is go and grab the plug and play model out of this public repository and put it into your application. And so that's how you get this model. And then we have this concept of views. So you remember I had the overview, and remember I had within there some telemetry was showing the current pressure and CO2 levels and humidity, and what we got? We've got temperature, humidity, pressure, and CO2, so 4 items. And over here we've got carbon dioxide, humidity, and things like that. So you can get the idea, and you can come around here and you can start configuring these. I'm not going to play around with this in the middle of a demo. But that's the kind of the idea behind this. We'll say, yep, it's okay to discard those. You remember I had a settings view where I could go and set the CO2 alert level. So you go and define all those things inside here. So that's the idea behind creating views. And you can create views which are really kind of make sense for your application. Okay, so the next thing I've got up here is rules. And you can go and define various rules. So you can see in here, I've got a rule in here. So I'm saying if the CO2 levels are greater than 500 parts per million, then I'm going to send an email. But maybe I want to go and call a webhook and an Azure function, for example, and kick off some sort of flow. Or maybe I want to go and use Microsoft's Power Automation or Logic Apps. So I can call those and trigger off a business process, which again are predominantly low code or no code business processes to make all this kind of work. So that's kind of the That's what you can do around our rules. Now, analytics is kind of cool as well. So we can go in here and create a query. And we'll go along here and we'll select CO2 monitor and we'll look at parts per million. And I'm going to group these by device name. And we'll go and analyze. And you can see I've been running this since around about, when was this up and running? This was running since November. And you can see that I can stretch this out and I can look at the data and I think, that's kind of curious. What's been going on here? And you can start drilling into the data and you can start seeing various correlations between the data. Now, I suspect I was actually playing around with this one and I was probably testing it to kind of figure out what was going on. But you kind of get the idea that it kind of gives you the ability to start drilling in and finding interesting relationships behind the data. Now, in this case here, I've only got one data. Maybe there is a relationship between temperature. I'm like, if it's a cold day, I guess we might be more likely to close the window. So we could find that maybe the correlation there and have a look at the data. But you kind of get the idea behind that. So really nice solutions for being able to deal with and look at the data, set up rules. You can also create jobs and do kind of lots of interesting things. But the main point about this is I didn't have to go and write any code for this. I'm really going in there and creating views, very much drag and drop, setting properties and things like that. Alrighty, thanks, Jared. Yeah, feel free. So someone said they're in Sydney. Cool, someone's from UCID by the looks of things, so nice. Okay, right, we'll go back to the slides. As I said, feel free to ask questions and I will do my utmost to keep an eye on those questions as we go. Okay, so the next part I'm going to show you around the Azure Sphere CO2 monitor. And I want to talk about this. Now, I just want to decouple one thing. I don't want you to walk away with the impression that I can only use Iit Central with Azure Sphere. That would not be true. I can use Iit Central with a whole range of different styles of devices. This talk and the focus of this talk is around using Azure Sphere. And hopefully I'll kind of explain to you a bit about why you might want to consider using Azure Sphere as a secure, by default, by design device for your IoT solutions. Okay, so this solution that I'm going to show you, it's based on, I'm using the Avnet Azure Sphere Starter Kit. And you can see this area here, hopefully you can see my mouse. On the bottom left of that board, you can see it's Azure Sphere, and that's actually the microcontroller. That's the bit of silicon in there. It's got some storage, silicon, and memory in there for running your IoT applications. It's actually got some nice collection of sensors. So over here, I think it's called the meme sensor. There is temperature and pressure. I think it's on there. And you can go and put in these two sockets over here. These are called click sockets. And you can see on these boards over here, they are called click boards. And the idea behind this is you can take these click boards and you can plug them in to your into the click sockets. So I'm going to plug in a buzzer. So I get a micro buzz click. And the other click that I'm putting on is a micro CO2 sensor. And that's kind of look. And in fact, I'm pretty sure in the next slide, this is the setup that I've got sitting on my desktop. So it's the Avnet Azure Sphere Starter Kit, and I've got the two clicks plugged into it. So I've got the buzzer on the left, and in the middle, I've got the HVAC or the CO2 sensor. So this is a setup that I've got connected up to my developer environment. Okay, so the next thing I want to talk about is why Azure Sphere. And the first thing, I think if you've done anything around IoT, you'll appreciate that one of the biggest challenges at the moment around IoT is security. And of course, why is that an issue? Is because often they can be an easy target and a lucrative target for hackers to make money. I guess that's fundamentally what people are trying to do. So they hack into systems and they take over them. And if you kind of follow the news recently, you will be aware of what happened in the US with the pipeline in the kind of Florida area, Texas, Florida part of the US, where hackers hacked into their systems, which effectively IoT systems, and locked down the oil pipelines. And this was obviously hugely troublesome to the country because people couldn't get hold of fuel. And there was obviously people queuing for hours to try and get the fuel, the small amounts of fuel that were available. But that's one that's been an example in the press recently. But there are lots of different styles of hacks. You hear about smart cars or medical devices or children's monitors, baby monitors, and things like that. So these are the kinds of issues that we kind of deal with. And too often, our IoT devices are too easy to hack into. And the whole rationale behind Azure Sphere is to make sure that Azure Sphere IoT devices are locked down by default and they're secure by default and by design. And I'll talk about that in a bit more. This is another classic example people love to talk about. This is the internet-enabled fish tank. And most of us think, what a fantastic idea. I'm going to automate my fish tank. I'm going to automate the temperature, make sure the salinity is right. I'm going to automate the feeding of this. Unfortunately, what these folk did in this casino is that they put the sensor into the fish tank and they connected the sensor up to the corporate network. And then what happened is that sensor wasn't particularly secure. And then people were able to come into the lobby of the casino. They hacked into that sensor and they were able to hack onto the corporate network and into the corporate network databases and steal a lot of data. So those are the kinds of things you can have. So when you think about IoT solutions, often they can have unintended consequences. And that's really what Azure Spheres are really to guard against, these unintended consequences. So Microsoft and the industry have kind of got together and come up with what we define as 7 properties of highly secure devices. Now, I'm not going to go into all these in a lot of detail, other than I would encourage you to take a screenshot, or I think these links are probably in the talk chat for this, but grab this aka.ms/7 properties of highly secure devices and go and check that out. But fundamentally, there are things like what's called a hardware root of trust, which is an unforgeable ID or ID in a set of certificates that identify that device. So you can't have someone swap that device out because it's always got that, or have that device masquerade as something else, because it has a burnt-in hardware root of trust. Again, things like certificate-based authentication are super important. So too many IoT solutions get hacked into because they're using username and password. And you know that, hopefully you appreciate that if you try hard enough with passwords, then invariably you can actually break into systems. So there was a really good example of security cameras that were dotted around the east coast of the US, I think it was. And they all had the same username and password. And what happened is that hackers got onto those security cameras and then they did a denial of service attack on the US DNS servers and brought down the DNS, or brought down part of the internet for the east coast of the US. So these are the kinds of things you guard against around using things like certificate-based authentication. We've got error reporting. You don't know what's going on with your devices unless you can error report and understand what's fundamentally happening. So error reporting is super important to be able to report back to a central view of what's going on with these devices. So you get access to these devices, you can understand, this device is misbehaving, it's crashing for whatever reason, and you can see the information in the error reporting. We can also look at this data and say, that's interesting. We can see that there is a consistent attack vector that is trying to penetrate and into these IoT devices. We want to make sure that we are mitigating against these new styles of attacks, because that's the biggest challenge around IoT security. It's a moving target. And if we can start saying, that's interesting, what's going on here, things are changing, this is a new style of attack, we can look at it and say, okay, we understand that what's going on. We can patch the operating system for the Azure Sphere and then distribute that out to all the devices and mitigate against a new style of attack. And obviously what hackers typically go for is they normally go for, I guess, low-hanging fruit. They go for systems that are easy to hack into. They will go there first. If they go to and figure out, oh, this is running Azure Sphere, it's highly locked down device, it's probably not worth my time and I'm going to move on to something else. So there's a lot of that kind of rationale in there as well. So Azure Sphere. So what is Azure Sphere? So Azure Sphere is made up of 3 components. Excuse me. So Azure Sphere is made up of 3 components. It's made up of an Azure Sphere certified microcontroller, and that is from our silicon partners. The main one at the moment is MediaTek, and they produce the Azure Sphere microcontroller, and on that there is a burnt-in hardware root of trust is built into that. And then hardware partners that we work like Avnet, for example, will integrate that MediaTek Azure Sphere microcontroller into a solution that you can go and use. The next part of the overall components that implement these 7 properties is the Azure Sphere OS. And the most important thing about this is it has ongoing updates because security is a moving target. As soon as you think you've got everything sorted out, there is a new style of attack that's going on. Now, Azure Sphere OS is actually a hardened version of embedded Linux. So we also benefit from what's going on with the general Linux communities. So we can understand, okay, that's interesting. We're seeing that there are new styles of attacks against Linux kernels, and we can make sure that we mitigate against those as well. So that's the kind of what we're doing around Azure Sphere OS. The next part, or the third component of what makes up Azure Sphere, is this thing called the Azure Sphere Security Service. And its role fundamentally is to guard each device, but it's the thing that kind of brokers trust between the device and the cloud. It's responsible for renewing certificates. It's responsible for aggregating emerging threats that are coming through the system. And it's also there for app reporting. And in the start of applications, you go and do, if your application was to crash, then you can have what's called an exit code. And you would say exit code, I don't know, 15. Exit code 15 means something in your application. There was a problem connecting to a sensor on the device and it's crashed. So it means that you need to go and look at your application because there's a problem in that application. So those are the 3 components. You've got the silicon, you've got the operating system, and you've got the cloud service. The Azure Sphere Security Service. Now, Azure Sphere, the microcontroller, just getting into this a little bit more detail without completely drowning in detail, you'll see that there are 6 boxes. And you'll see that there are 2 boxes here which are highlighted with red, highlighted in red. Those are microcontrollers. So this is what's called a multi-core microcontroller. So there are actually 5 microcontrollers on this bit of silicon that goes up into an Azure Sphere. 3 of those microcontrollers you can go and put on your custom code. So it gets to be like a really interesting mix of how you think about your applications. So some parts of your application might require that might require it for real-time processing. There might be something about a sensor that you're building that requires highly deterministic timing. And that's where you'd go and put on these real-time cores, those applications. You've got 2 of those. They're called Cortex M4s. The other core that you can go and deploy an application on is what's called an application core. And this is a Cortex A7. And this Cortex A7 is responsible for a number of things. It's responsible for running the Linux kernel. It's responsible for running the over-the-air update systems. It's responsible for certificates and all those types of things. But you can also run your own application on the Cortex A7. And what you're doing when you build an application for this is you're actually building a POSIX compliant application, a POSIX Linux application that you're running on the Cortex A7. So if you've been doing some Linux development, you can use those same skills across onto the Cortex A7. So really interesting mix of being able to build what we call high-level applications, which are typically less timing sensitive. maybe timing down to the hundreds of milliseconds, maybe not down to the microseconds or nanoseconds of fidelity that you might get and need on a Cortex or for a real-time application. That you want a really fine-grained timing. You'd go and do that on a Cortex M4. So fundamentally on this, you can have 3 applications running on an Azure Sphere. So you can really create quite sophisticated applications. And it actually gives you quite a lot of access to raw CPU, as well as memory resources and storage resources by spreading the workloads across those 3 cores. Okay, so the next thing I want to talk about is a developer tools. Hey guys, I'm seeing you're asking questions. I'm actually going to jump to those questions at the end because I just need to kind of fully understand those questions. So keep those questions coming in, but I have spotted them, and I will kind of get to them. And I think I've asked what kind of devices are compatible. So no, it would not be a microbit. So you would need an Azure Sphere device, is what you would target. And there are multiple Azure Sphere devices in the marketplace. So the developer tools for building Azure Sphere applications, they're all free of charge. You can go and build applications on Windows and Linux, and to a certain extent on Mac. The reality is most embedded developers are doing it on either Windows or Linux, and that's kind of where we target. So the developer tools are free. So on Windows, you can use Visual Studio 2019 and 2022. And it has an integrated debugger, and the integrated debugger is magic. It's fantastic to be able to easily connect into your solution that's running on the device, and then step through your code and understand where issues are in your code. You can use Visual Studio Code, which again is a free of charge IDE, and you can use it on Windows and Linux. And again, it has an integrated debugger. You can do it from command line, and there might be a reason why you might want to do command line. You might want to integrate it into an overall tool chain. Let's say you're a manufacturer of devices and you've got a process in which you want to be able to compile, test, and deploy, and you want to integrate that into an overall process. And the other thing, there is the Azure Sphere SDK. Cool, so do keep questions coming on, and hopefully I've answered that question, Renee. Okay, so the next thing I'll talk about is something called Azure Sphere DevX. Now, Azure Sphere DevX, the main goal behind this is a library that simplifies your development experience on Azure Sphere. Now, you don't have to use it. You can write your own code, but I would encourage you to at least look at it because what it can do is really significantly simplify your developer experience on Azure Sphere. Now, the other important thing about this, it's community maintained library. It is not an official Microsoft library. And the core concepts behind Azure Sphere DevX is you've kind of got the idea of bindings, and I'll explain what those are in a moment. You've got binding functions, and you've got binding callbacks. And again, this will become more apparent when I do the demo, which is now. Alrighty, so we'll just drop down out of that. So what I've got, I'll just bring up my demo notes. Okay, so what I've got up here is I've got Visual Studio 2022, actually, I think it is. And it's just the latest version of Visual Studio 2000 and 2022. But as I said, you could equally do this on Visual Studio Code on Windows or using Visual Studio Code on Linux. And if you looked at any any C application, that's the other important thing about it. This is a C developer experience. So this question comes up quite often. Now this will change potentially in the future as well, but for now it's C. And I would strongly encourage you, if you're looking at a career potentially in IoT and embedded software development, I would strongly encourage you to start skilling up around C and C++, because it really is the language of embedded software development. And I think it will be for quite the foreseeable future. So keep that in mind if you think, oh man, I'd love to get into this world. What are the skill sets I need? C development, I would put it kind of the top of your list. So what we've got in here is you've done any C development before, you will appreciate that there is the main entry point into the application. And these are calling off to C functions. And I've got a loop down here, and you might think that's a bit odd. Why has he got a loop? My application is just going to go loop forever. This is what's called an event loop. And the whole idea behind an event loop, it provides a way of coordinating different activities across your solution, across the device. And what happens is that an event loop runs, and it goes around, kind of think about it's going around a circle. And it's saying, is there any work for me to do? Is there any work for me to do? Is there any, and then somewhere in your application you may say, well, actually, there is some work for you to do. Every 30 seconds, I want you to go and measure the sensor. So you would go and put on the queue for the event loop to say, every 30 seconds, I want this event loop to pick up on this and say, there's a bit of work I need to do. And that bit of work to do is to go and measure the sensor. And maybe every 20 seconds, the better work to go and do is to go and publish that data to Iit Central. It's that kind of idea. So it runs around a loop and it effectively looks at a job queue and says, is there any work for me to do? Is there any work for me to do? Yes, there is some work for me to do. There's a timer which is expired. I need to go and call the bit of work that is part of that timer. So that's fundamentally what's going on. So it's an event loop, and it's a very common pattern for Linux applications, and it's a very common pattern for IoT solutions, is very much this. The other beauty of it is it runs on a single thread, and it means that you use less resources. Now, on Azure Sphere high-level applications, you can use multiple threads, but in general, we try and advise against it. Use an event loop and a timer where possible. So I'm in main.c, and I've got an include for main.h. And we're going to jump across to that, F12. And again, if you've done any C programming before, you'll understand there's an include. It's a bit like an import in Python, same kind of idea. And if I come down through here, what I've got various device properties and content properties and things like that. I'm not going to go into this too much. You can look at that in your own time. Okay, so the other part of the solution, now I've touched upon this a couple of times, which, as I said, Azure Sphere solutions are secure by default. And you need to go and declare everything. Otherwise, an application will fail when it tries to access a resource. So for example, in here, I've got some GPIO. So I've got some pins that I want to access. So I've got an Azure connected LED. So when this device connects up to Azure Iit Central, a little light will come on to say I'm connected. I've also got a button on there, so it's called button B. And if I don't declare these in the manifest, then when the application tries to connect to it, it will fail. And the whole beauty behind this is if somehow someone managed to hack this application and started saying, well, that's interesting. What else can I do to this device? What can I do that this application was never intended? If they started to try and connect to other GPIO that isn't declared in the manifest, it will fail. So that's the idea behind it. So you can see I've got pulse width modulation. I've got I squared master. I've got analog to digital. And these are the connections for my Iit Central application. And if I don't declare these endpoints, then I will not be able to connect to Iit Central. And the whole idea behind this is, you remember I talked about the fish tank, where they were able, that fish tank sensor, they were able to get onto that sensor, and then they were starting to be able to get to network endpoints that this sensor had never had in mind when it was built up, when this is built. But the beauty of saying allowed connections, that this application can only ever talk to these endpoints. So if someone managed to hack onto this device, they would not be able to start talking to random endpoints. So that's kind of one of the really important concepts behind it. Okay, so I'm just going to build this application very quickly. As I said, the full example is provided on the link that I referenced at the beginning of this talk. Okay, so what I've done is I've added in a series of bindings. And I know that the first time you look at these and you'll think, crikey, I've seen lots of code. So I'll try going through these, but we have these kind of concepts of bindings. And bindings, just so you know, if you're a C person, binding is just a C structure. That's all it is. And I've called it a binding. And we've got bindings, we've got different types of bindings. This is a timer binding. You'll see down here, I've got an I squared C binding. And you see for the timer binding, got one up here, which is called publish telemetry, another one which is called read telemetry. So for publish telemetry, it's going to publish, or this timer is going to put onto the event loop every 6 seconds to say, I want you to go and call this what we call a handler. And it's actually just a C function. I want you to call this C function every 6 seconds. So that's what that means there. And then every 4 seconds, I want you to go and read the telemetry. I want you to go and read the CO2 sensor. And every 4 seconds, I want you to go and call this C function, which I'm going to show you in a moment. And then the rest of it down here is just to do a bit more with initializing those timers, those bindings. Okay, so the next thing, so now I've done that, I'm going to go back to main.c and I'm going to implement the first one. So this one up here is the read telemetry handler. So if I go back to my main.h and I come up to my read telemetry, remember I said this is the C function, so this is the read telemetry handler, and this is my implementation of read telemetry handler. And what it's going to do, it's going to read the onboard sensors, and then I'm going to read the CO2 sensor. And then what I'm going to do is I'm going to validate this data. I'm going to say, is the latest temperature, pressure, and humidity, are they sensible data? Is that sensible data? And I just do a validation check. And ultimately, I'm going to set this variable called telemetry.valid will be true or false based on the outcome of these tests. So that's the first handler I'm putting in there. And the second handler I'm going to put in is this one down here called, publish telemetry handler. And you remember in my main.h, there goes my reference to this handler. So remember what's going to be called every 6 seconds, the event loop is going to call this C function. And if I come over to my C function, you can see, okay, I'm going to check the data is valid. I'm going to check that I'm connected to Azure Iit Central in this case. And then what I'm going to do is I'm going to serialize the data as JSON. So I've got CO2 parts per million, humidity, pressure, temperature, and I've got some memory data as well. And then ultimately what I'm going to do is I'm going to publish that data. And it's as simple as that. I'm going to publish, you can see I'm serializing this data into a message buffer. And you can see down here, I'm going to publish it. I'm just going to publish this message buffer. And there are a few additional parameters, but you can find out more about that in the read through. So that's how this is going to work. Now I'm going to add in a little bit more, just in the interest of time, actually. I'm going to go back to my main.h, and I'm going to paste in another set of bindings. And down here, I'm going to paste in, whoops, I'm not going to paste that in. I'm going to paste this in. Alrighty, so I'm going to paste in what's called a device twin. Now, a device twin maps to a property. And what this is going to be looking at alert level. So I'm going to say, I'm going to set the alert level when it goes above 400 parts per million. So I want to be able to track that. And I also want to be able to report on the, so I'm just going to track the alert level. So from the cloud, from Iit Central application, I'm going to set the alert level. And then what I'm going to do is what's called a device twin binding and create a set of device twin bindings. And I'm going to pass in all my device twin bindings by reference into this array of device twin bindings. You'll see I've done the same thing here with timers and I²C. And then what I'm going to do is I'm going to pop across to main.c and I'm going to scroll down here a bit further to init peripherals and handlers. And I'm going to add in a little bit of extra code. Okay, so the first thing this is going to do, this is going to open up my I²C bus. I'm going to initialize a CO2. And the next thing I'm going to do is I am going to initialize what are called device twins, and I'm subscribing to them. I appreciate that I've gone through this probably marginally faster than you might have liked, but I just want to, I'm kind of interested of time. And the next thing I'm going to do is I'm going to paste in, so over here in my main.h, I've got my device twin binding, and it has a handler associated with it called set CO2 alert level. So I'm going to come across here to main.c, and up here, I'm going to paste in my CO2 alert level. And as I said, this is all thoroughly documented on the GitHub repo for this. And what I'm going to do, it will, when I get properties set on this CO2 function will be called, and then we're just going to set a breakpoint in this. Okay, so what I'm going to do is I'm going to deploy this application to the Azure Sphere device that's sitting on my desktop. So this will take a moment or two to deploy. And if you have done embedded software development before, you're used to the whole kind of concept that you've got to compile, you've got to deploy the code onto the device, in this case the Azure Sphere, and then you've got to attach the debugger to it. And there's always this kind of compile, deploy, attach to the debugger. Okay, so you'll see down here in this window, this is the output from the device. And in a moment, hopefully, this will connect up to Azure Iit Central. Okay, so we're connected. So you can see down here there's a message. Now you remember I set a breakpoint, and this was being set on a property. So what I'm going to do is I'm going to come across to Iit Central, and I'm going to go across the devices, and I'm going to cross the Seed Studio, and I'm going to go to the settings. And you can see that the CO2 alert level was set at 1,000 parts per million. Now if I, from the debugger, go and mark that and then hover over it, oh, actually that might have the, oh, because I'm on the wrong device. I'm thinking, why is that 400? Well, let me bring that up, and it would help if I connected to the right device, and you can see in this case it's 400. So what I can do is inside the debugger I can mark the variable that I'm interested, and if you look at the screen closer, you'll see it's got the value 400 in there. And as I step through the application, you'll see I popped up a message which says CO2 level greater than alert level. So look down on the bottom right hand corner, you can see that there goes the message. And that's the message that's been posted. Okay, so I'm just going to click on continue. And so that's how the application is running. So remember as well that I said in main.h, I said that if I go look at my timer, for my reading, that every 4 seconds, I'm going to be calling this handler. If I go F12 on that, that'll take me across to the handler. And I'm going to put a breakpoint on there. And in less than 4 seconds, this will be called. Oh, because I stopped. No, I haven't stopped the application. That's kind of weird. And I know it's working. Okay, there it is. I don't know why it got missed out before. Anyway, so this will be called every 6 seconds. So I go 1 and 2, oh, we had 6 seconds. So you can kind of get the idea behind this. So you can set up these timers. Okay, so that was the demo. So Azure Sphere DevX will significantly help you reduce the amount of code. And the whole beauty of it is that you get to focus on the code that you need to write. And that's the kind of the idea behind Azure Sphere DevX. Alrighty. So in terms of best practices, I'm going to go across these reasonably quickly. So the first thing about it is when you kind of build your application, you get to the point where you want to be able to deploy it into production, you should have this concept of deferred updates. Deferred updates give you the idea of saying, I want this application to be updated at 1 o'clock in the morning because users aren't going to be using this application. That's a kind of, but there could be lots of different criteria. We've got an application watchdog. Watchdogs are typically there to say, is this application working? Is this application working? And normally the watchdog will be updated. We'll update a timer. And then if that application fails, the watchdog timer won't be updated. And the system will say, that's interesting. The watchdog timer has not been updated. The application's died. and then restart it. So those are kind of things. Exit codes are invaluable for being able to diagnose. So always use exit codes. You'll again learn more about those when you're digging into Azure Sphere. Memory management, super important. If you can, always allocate static. And if you do need to go malloc anything, then make sure you follow it with a mem set. Make sure you initialize that memory, because that forces the memory manager to make sure that memory has been allocated to the application. And there's a bit about periodic timers as well. And the next thing I want to do is I just want to talk about a couple of other experiences. Now, the first one I'm going to talk about is this thing called Desktop DevX. Now, you might be thinking, oh, that's kind of interesting. Dave and Microsoft have been talking about Azure Sphere, but I don't have an Azure Sphere at the moment. What can I do to start playing around with this whole development and building these IoT style applications? And what I've written is something called Desktop DevX. And you can run it in Windows subsystem for Linux if you're using Windows, or if you're running Linux, you can go and build it natively on Linux. So what I've got here is, because you remember Azure Sphere, the high-level applications, they're Linux applications. So hence I'm using Windows subsystem for Linux to go and build a Linux application. And then what I'm doing is I've got main.c. So you remember how in main.h in the demo application I showed you before, it had these concept of bindings. So I've got GPIO bindings. You remember I had lots of timer bindings in the previous demo. Device twin bindings. I've got direct method bindings of different types, pulse width modulation controllers and bindings. So it's exactly the same model for developing, but you can go and do it on the desktop. And the way this works is, and this won't be the way, I've actually got a real Azure Sphere, and I'm using what I call Azure Sphere Remote. So this application, which is actually going to be running on the desktop, is going to be talking over my Wi-Fi network to this Azure Sphere that's sitting on my desktop, and it's going to be manipulating the GPIO and I2C and the pulse width for the speaker and things like that. So that's kind of how it's working. Now, the advantage of running this on your desktop is this. If I go and hit kick off debug and build, you'll see that it's almost instant. And that's because I'm not having to deploy the application from my desktop to the device and then attach the debugger. Now, depending on the noise cancellation leveling on my speaker, you will also be able to hear this peeping. It makes a pip sound every so often as well. But I can come along here, and if I go into my application, I can, where's a good place? In here, I'm publishing telemetry somewhere. I'm reading telemetry, and I'm publishing telemetry. Here we go. And I'll go and put a breakpoint. And I can go and hit that breakpoint, and you'll actually hear the speaker potentially in the microphone over the speaker as well. And I can step through my code and understand what's kind of going on. So those are the kinds of things. So this is what Desktop DevX is about. It's going to give you the experience of building an Azure Sphere application, but doing it in the desktop, building a Linux-based application. In this case, I'm remoting the calls from my desktop over my Wi-Fi to a real Azure Sphere, and using all the hardware sensors that I've got on that device, but using them remotely. That's the kind of idea behind Azure Sphere DevX. Okay, so that is pretty much the talk I want to talk about. So now the place where you can go for these resources. So if I bring up my browser, so you can find things like desktop example. It's a desktop DevX that's sitting up there. You'll find Azure Sphere DevX, which is the main library that I'm showing you. You've shown a whole stack of examples. And you remember that up on the Azure Sphere Gallery, so just go search for Azure Sphere Gallery. You go in there and go looking for the CO2 solution, and you'll find the complete solution up there. And you can see how that kind of works. Okay, so that's pretty much the talk. Useful. I apologize. In some places I went just a little bit faster than I might have liked to have. But the joys of doing talks live. Okay, so I'm just going to go and look through the questions here. So there's a question from Jared. Okay, so it sounds like you're doing some interesting work around quality and monitoring. So that's really cool. So, okay. So Renee, you asked me a question about, I thought you said I didn't have to use an Azure Sphere with Iit Central. That is absolutely true. Um, but the developer example that I showed you, that is really using Azure Sphere. So you're quite right. I could go and use a microbit, and I could Bluetooth it to my phone so I could get internet connectivity. I think there's a bridging app that you can use for your desktop or your phone. And then you could stream that telemetry to Iit Central. So you're absolutely right. So sorry, I did slightly misunderstand. But you could absolutely use your microbit for this. But with your microbit, you would not really be in the world of creating secure IT solutions, but absolutely great fun for prototyping and doing some things like that. I think those are the main questions that I got. So hopefully this talk you found useful. I'm also going to bring up one last slide. Do check out more learning resources. So if you go and search for Microsoft or MS Learn, in fact, the easiest way, I'll just bring up my browser. I'll just bring up my browser. And I'll bring that up here. So go search for MS Learn. And go search up here for Azure Sphere. And then inside Azure Sphere, scroll down here and you'll see two solutions. You'll see developing secure IT solutions with Azure Sphere and IT Hub. Another one down here for developing IT solutions with Azure Sphere and Iit Central. And those will step into way more detail. Probably, in fact, I think in the CO2 solution that I talk about, I think I point you off to these learning resources as well. So that's pretty much the talk. Check out Azure Sphere DevX on GitHub. You'll find all those resources up there. MS Learn, and let's build secure IT solutions for the future. So thank you very much, and I'll keep an eye on the questions. And yeah, great. Thanks, Renee. So you spotted that as well. Anyway, thank you so much for joining in. Do feel free to follow me on Twitter. If you've got any questions that you thought of after this talk, then feel free to ping me on Twitter. Super happy to answer them on there. And if we can have a more detailed conversation about that. So thanks so much, and enjoy the rest of your evening or day or wherever you are in the world. Thanks again.
Great. Thank you so much, Dave. And thank you to everyone for tuning in and engaging with us in the comment section. As you mentioned, if anyone wants to touch base with you after, follow up any further questions you might have that you didn't think of right now, please do so with Dave. And all those links that we've just gone through in the presentation are available in the check-in link. So go check that out and check in. The event code for that one is 14872, and the same one applies to the survey. And we've just put in the link to the YouTube channel. So if you want to go back and reference this recording again, you can do so straight after today. Thank you again today for presenting. Thank you to everyone for tuning in. Have a good rest of your afternoon, evening, or morning, and we'll see you next time for another Microsoft Reactor live stream event. Thank you.
That's awesome. Thanks, Sarah. Thanks, everybody. Take care. Bye-bye.
Bye.